Hi folks, I'm hoping to share the process and experience of replacing this 10 foot by 12 foot metal shed that is on its last legs. You can see the rust along the bottom, and inside is often wet and rotting out, and it smells in here because of rats. There's tons of condensation inside there when the weather gets cold. And I'd like to replace it with a timber frame shed of similar dimensions plus the same gambrel roof style. And so this one, the shed door, is 5 feet tall, and I'm 6 feet tall, so it would be nice to make the door another foot or a foot and a half taller, and then so the whole shed would be a foot to a foot and a half taller, or even 2 feet considering the thickness of timber framing materials. So I've already made the design, drew it out of the timber framing on Shaper 3D, and let's go have a look at it. Hello, we're inside now, and it's been several weeks since I made that video snippet of the old shed, because as I started thinking about sharing this design that I have in front of us here, I realized I better have everything covered as good as I can, because I'm hoping to get some feedback, and I didn't want to ask for feedback if I know of current deficiencies or errors. Yeah, so here's a quick visual overview of the size of the shed and the shape and the timbers involved. And but before I continue, I'm going to turn off my camera feed because the last time I tried this, it got too glitchy, and I'm figuring my camera is taking up too much bandwidth. So just let me turn that off for a minute. All right, so while making this design, I ended up referencing this particular book. Let me see if I can pull up some photos. Yeah, this book, Building the Timber Frame House, and it was actually printed in 1980. And then a few years later, when I was in my late teens, I bought a copy because I was dreaming of making a timber frame house. But that never happened. And so I'm hoping that building a timber frame shed can fulfill that dream. Yeah, so I took a few photos of some of the pages. So here's a page that starts talking about an introduction to joinery. And this page describing some timber layouts, how to go about it. Here's a page showing knee brace joints, which is a common joint, and giving some details about how to do it and what to watch out for. And then here's another page about some corner joints at sails, and even recommended dimensions depending on what size beams you're working with. And then there's a chapter 6 on building for strength. So that was helpful because of my uncertainties about what was adequate. And they give some thoughts and ideas on structural design. And then how to check tenons for sufficient size to resist shear. And then even calculating the loads on some of the timbers, like for the floor, and how much load is this central beam going to be taking, for example. And they have tables in the back of the book. Yeah, that's what this photo is about. It's another page talking about designing beams using tables with step-by-step instructions. It turns out, because of the relatively small size of timbers I used in this shed, those tables weren't helpful because they're dealing with 8 by 8s and larger. But either way, just seeing how to go about this was very helpful. So then, yeah, some of the high level design considerations that came to mind after looking at my situation and the book I have was because the structure is going to be small, I chose to use sort of scaled down timbers also, not just a few large timbers, but scaled down. And part of that is because there was some simplicity in finding these largest timbers that I got here. Like, for example, this one is only a 6x6 dimensional lumber. So it's actually only 5.5 by 5.5, but they're readily accessible at a local building supply store. And so this kind of post, as well as this sill plate and a few others, are 6x6 or actually 5.5 by 5.5. But they're dimensional lumber, so they're very consistent, which is nice. That um, what else? Oh yes, I chose a variety of joinery rather than just choosing the simplest joints. Um, and we'll look at that a little closer in a minute. And then one of the big challenges was to maintain this gambrel roof shape, because that combined with the small timbers or the small size of the building actually did add sort of complexity that I couldn't find any documented way to address it. So I addressed it in my own way, and we'll see what people think about that. So based on those design considerations, some of the general rules I came up with, or the results, is I used, like I said, 6x6s. That was the largest. This plate here is a 4x6, so that's the next size down. Some of these joists, like this one here, is a 4x4. And then I even dare to use just plain old simple 2x2s. So all of these knee braces are 2x2s. And that might sound sort of weak and risky, but I am choosing Douglas fir species for all of this. I mean, that's what happens to be available, but that's a good thing because that is relatively strong compared to the usual pine or spruce or the true firs such as subalpine fir and grand fir. So hopefully that is okay. Another general outcome is that I used 3/4 inch doweling for all of my pegs where I needed to peg a joint. And there is one exception to that, which I'll get into detail later. Then I assumed the floor load to be 7.5 pounds per square foot of dead load and 25 pounds per square foot of storage load, since this is basically a storage shed. So that comes to 32.5 pounds per square foot. And that's what I used when doing structural calculations on some beams. And I used calcs.com free calculator. That's calcs.com free calculator for doing beam stress analysis and some equations from the book for doing tenon shear stress analysis. And analysis was done on 4 representative beams that were carrying the most loads relative to their size, like just based upon intuition. For example, if we look at the bottom of the foundation, we can see where the concrete supports are. And so there's no concrete support under the middle of the front sill here, this 6x6. So by intuition, it's not hard to imagine that, okay, this sill beam spans 10 feet and it's going to have the most stresses on it. And so I could calculate those stresses based using calcs.com. And then I did 4 other representative beams also, such as this summer beam and 2 more. And the outcome of that was I did end up changing some 4x4s to 4x6s. And so I'm feeling pretty safe about the structural integrity at the moment. And perhaps that could be the topic of another video showing how I did the structural calculations. The one little bit of uncertainty is the 2x4s for all of the knee braces. But because there are numerous of them all around, I suspect it will be okay, combined with the small structure. Okay, let's zoom in now and look at some of the detail of the joinery. First, I'll turn off stuff we don't want to look at for now. Yeah, all right. So what I did, these sections are 4 foot by 4 foot, and then these sections in here are 2 foot by 2 foot, and that's so it's easy to apply standard 4 foot by whatever sheathing. And then I have this center beam, and the back half of the shed is simply a rotated view of the front half of the shed. And then I did that so that I wouldn't have these major joints directly opposite each other. So I don't have a large beam right here. And so they're offset and spread the load a little bit. So here, if I zoom into these 2 pieces, then I can hide, for example, this summer beam so that you can see the joints. So this joist going into that beam, that summer beam that belongs here, is a simple dovetail joint. And then the larger summer beam, which goes into this girder across here. So that joint is called the house dovetail. So it has larger surface area for supporting the beam, and so it can bear more load. And that's basically it for details of the floor. And then I will turn on the front vent and zoom out a bit. So this is the front of the shed, and then here, let's, well, I'm going to turn on the roof too, because the roof has, or rather the bay, I guess it is, I got the stringer beams front to back, and we want to look at some of the detail around these joints. So hiding this plate across the front, and then we can see the joint involved here. And so the post is 6x6, and that plate that comes across here is 4x6, and that's why it doesn't span the breadth of the post. And it has a tenon going into the post, and then the 2 dowels. And those are, yeah, 3/4 inch dowels. If we turn on the exact front view and show the hidden edges, then you can sort of see how deep the mortise and how long the tenon will be. So if I zoom out till we got a 1/2 inch squares showing in the top right, then you can see this tenon is 2 inches and a bit. One of the unconventional things I had to do is related to the long 12-foot beams that create the 5 peaks of the roof. So again, I guess if we look at a direct front view and zoom in, and if I hide a few of these things, but you can see looking at this cross-sectional view of that long beam, it's actually a 4x6 on edge or inserted slanted with one surface cut off so that I'd have a flat surface on the outside of the shed and a flat surface that's flush with the intended roof line. And so that causes extra complexity on this joint here. Yeah, you can see the odd joint there. That will be more difficult to build, but I didn't have a good solution to that. And looking at how this beam is attached to the post provided some complexities. Let me see if I can turn these things back on. And I'm going to also show how the roof truss connects into the top of the post here. So maybe it's that one. Yeah, so here's the 4x6 beam on edge, and that roof truss piece is going to be going into there with a tenon. Unfortunately, most of the bearing, the load bearing, will be on this surface, which is a large surface. So that roof truss piece, or the rafter, I guess, will be pegged in place with a peg through there, but that will have to be done after I first attach the beam to the top of the post. So if I hide that beam, then you can see, so it first lays on top of the post with a peg going into this hole right there, and then that rafter piece will go into that, and then a peg going into there. So then moving on to where the next ridge beam would be, which is there. So let me turn that on. Yeah, you get a little bit of a non-conventional arrangement here. So again, ridge beam is actually another 4x6 legged flat or on its side. You can see, so the outline, the main outline is there, and then I shaved off a bit over here so that again I'd have a flat surface that's flush with this part of the roof, and then a flat surface which is flush with that part of the roof. So if I hide that beam briefly, then you can see the kind of joint we got here. We got this what's called the queen post because it's smaller than the central king post. And if I hide this, then you can see, yeah, there's a mortise there for the rafter piece. And on the other portion, there's also a mortise for the other rafter piece. And I made them symmetrical so that it's just easier to craft it. And so one concern here was that, let me see here, I gotta hide this queen post. These tenons are a little bit on the small side. And so for that reason, this is where I used 5/8" dowels in the queen post. If I turn on the hidden edges, yeah, then it's easier to see that. You can see the outline of the tenon and the 5/8 inch dowels. I'm not too concerned about that because, as you can see, just by where this truss is, this truss piece, it's going to be coming weighting down into the queen post, so there's going to be very little pull, trying to pull it out of the queen post, because the bottom edge of this is right into the top of the adjacent vent post. Maybe I should turn that back on. Yeah, so we got a post top here, so that's going to stop a lot of forces going sidewards. So this truss piece, as well as this one, they're basically just resting in the queen post and not getting pulled sidewards. So that's why I figure these tenons are large enough. Okay, then turning the hidden edges off again and moving on to the king post. So we'll make that visible and also make visible the beam that goes from front to back. And let's just get ourselves orientated a bit here. Yeah, okay, so that's what we're looking at. And I should exit isolation so we can see more of it. So this post here is not so unconventional. I'm just gonna isolate those timbers so we can see them better. Again, the back timber, if I select it, then you can sort of see the main outline of it. So it's another 4x6 on the flat side with shaved off over here and shaved off over there. And if I hide it, then you can see the king post with, I'll go exactly front view and turn on hidden edges again. Then you can see the tenons from this truss piece coming into it and the tenon from the other truss piece coming into it. And those are back to 3/4 inch dowels. And not only that, you can see that there's a lot of wood on the truss piece resting on top of the post. So the tenon itself doesn't carry much load. And so I think that should be fine. So then backing out a bit, I'm going to turn everything on and look at, we just got some more braces, knee braces. They're exactly the same dimensions as these ones down here. So this knee brace down here is exactly the same dimension as these ones here. And that's to stop the roof from getting twisted. And then one more set of braces underneath here also on this end and one on the other end. Exactly the same, symmetrical right there. Okay, I don't think there's too much more detail to talk about, or not that I can think of at the moment. I think for me, the next two steps are to practice or find a technique for cutting a bunch of these dovetails into joists and beams using a router, because they are fairly small joints, so then precision is that much more important. And it would be neat to be able to do it with a router. In particular, I have a 3D printer, so I can print the exact shapes of these joints, like a flat view, and then hopefully that can be used as a template for a router in some way. So that's one thing I want to work on, while hopefully I get some feedback of this video on YouTube. And then another thing I'm going to continue working on is printing out a scale model of this on my 3D printer, just of the individual pieces, and then seeing if I can manually clip them together, sort of like a little bit of a puzzle. All right. Thanks for watching. Bye.